In the middle of Antarctica, far from any coastline, there is a place where the cold feels permanent. Temperatures can drop below -80 degrees Fahrenheit, and the ice stretches so thick and wide that it hides the land completely. In 1957, during the International Geophysical Year, Soviet scientists chose this harsh location to build a research base. They named it Vostok Station. At the time, their goal was simple and practical: study Earth's climate, measure ice thickness, and understand how this frozen continent worked. No one arrived expecting a discovery that would quietly reshape how scientists viewed Antarctica itself. In those early years, researchers relied on seismic surveys and basic radar equipment. These tools sent signals down through the ice and measured how they bounced back. Most of the time, the results were predictable. Ice reflected one way, solid rock another. But beneath Vostok Station, something felt off. The signals returned smoother, flatter, and far more uniform than expected. It looked less like rugged bedrock and more like a level surface hidden deep below. At first, this anomaly was easy to dismiss. Antarctica is full of strange readings, and equipment in extreme cold is not always reliable. As decades passed, technology improved. By the 1970s and 1980s, airborne radar surveys allowed scientists to map the underside of the ice sheet with far greater accuracy. What they saw beneath Vostok Station could no longer be ignored. Independent research teams using different instruments and methods kept detecting the same feature. A massive, flat region lay beneath nearly 4 kilometers of ice. And it wasn't solid ground. It reflected signals like liquid water. This realization challenged a long-held assumption. Antarctica was believed to be frozen solid all the way down. The idea that liquid water could exist at such depths, under such pressure and cold, seemed almost impossible. Yet the data kept pointing in the same direction. Beneath the ice was a vast subglacial lake. It was eventually named Lake Vostok after the station above it. As researchers pieced together its size and shape, the scale became clear. Lake Vostok is roughly 250 kilometers long and up to 50 kilometers wide, making it comparable in size to Lake Ontario. It holds an enormous volume of fresh water, locked away from the surface world. Based on ice flow models and sediment data, scientists estimate that the lake has been sealed off for at least 400,000 years, and possibly much longer. The reason it remains liquid is not magic, but physics. The immense weight of the ice above creates pressure that lowers the freezing point of water. At the same time, heat rising slowly from Earth's interior warms the base of the ice sheet. Together, these forces keep the lake from freezing solid, even in one of the coldest places on the planet. This is where the discovery shifted from geography to mystery. A lake isolated for that length of time is more than a body of water. It is a preserved environment, untouched by modern pollution, modern microbes, or human activity. Scientists immediately began asking careful questions. What does the water contain? What minerals have dissolved into it over hundreds of thousands of years? Could microbial life exist in complete darkness, under extreme pressure, without contact with the surface? Yet unlike deep-sea mystery sites or lost underwater cities explored by divers and submersibles, Lake Vostok could not simply be visited. Antarctica is governed by the Antarctic Treaty System, an international agreement designed to protect the continent for peaceful scientific research. Any action that risks contamination is treated seriously. Drilling directly into a sealed lake raised immediate concerns. Introducing surface bacteria, chemicals, or drilling fluids could permanently alter an environment that had remained stable for ages. This is how Lake Vostok became both discovered and restricted at the same time. Scientists knew it was there. They could map it, measure it, and model it. But touching it was another matter entirely. Early drilling efforts near the lake were paused and redesigned repeatedly as researchers debated how to proceed without causing harm. Unlike sunken structures or unexplained ruins uncovered through underwater archaeology, this mystery did not involve visible artifacts or ancient walls. The intrigue came from absence. A vast place existed, known only through indirect measurements, sealed beneath ice thicker than most skyscrapers are tall. By the time Lake Vostok was widely accepted as real, it had already earned a unique status in science. It was not questioned whether it existed. That part was settled. The true mystery was what remained hidden inside and whether humanity should even rush to find out. Curiosity pushed forward, responsibility pulled back, and that tension between knowing something is there and choosing how or if to explore it is where the story truly begins. By the time Lake Vostok was accepted as real, scientists faced a strange problem. They knew the lake existed, they knew where it was, and they even knew its rough shape. What they did not know was what it actually contained, and reaching it directly was not an option. So instead, researchers turned to a careful workaround, studying the lake without touching it. The key came from ice cores drilled above the lake. For decades, teams working at Vostok Station had been drilling deep into the Antarctic ice to study past climate. These ice cores act like frozen timelines, preserving tiny bubbles of ancient air and layers of snowfall from hundreds of thousands of years ago. But near the base of the ice sheet, something unusual appeared. Instead of normal compacted snow, scientists found layers of ice that had clearly formed in a different way. This ice had not fallen from the sky. It had frozen upward from below. As Lake Vostok's water slowly touched the underside of the ice sheet, small amounts refroze and became trapped. This accretion ice, as researchers called it, carried chemical fingerprints from the lake itself. It was the closest thing scientists had to a sample without breaking into the lake. When these samples were analyzed in laboratories in Russia, France, and the United States, they revealed a quiet but important story. The ice contained dissolved minerals and salts, suggesting the lake interacts with bedrock below. It was not a sealed glass container. It was slowly exchanging material with the earth beneath it. Researchers also detected organic compounds, including carbon-based molecules that are often associated with biological processes. That finding immediately drew attention. Organic material does not automatically mean life, but it raises questions. Could microbes exist in complete darkness, under immense pressure, with no contact with sunlight or the surface world? Scientists studying extreme environments already knew that life can survive in places once thought impossible. Deep-sea mystery research, for example, had shown that microbes thrive near hydrothermal vents. Lake Vostok offered a different kind of test, sealed under ice rather than ocean water. Some studies went a step further. In the late 1990s and early 2000s, researchers reported possible microbial signatures in accretion ice samples. DNA fragments and cell-like structures were observed under microscopes. The idea that Lake Vostok might host microbial life began to circulate, though always with careful language. No one claimed proof. The evidence was suggestive, not conclusive. That caution was necessary. Other scientists quickly pointed out a major problem. Drilling into Antarctic ice requires fluids to prevent boreholes from collapsing. At Vostok Station, a mixture containing kerosene and antifreeze was used for years. Even tiny traces of contamination could alter samples. Surface microbes could be carried down during drilling. Chemical residues could mimic biological signals. This led to a split in interpretation. One group of researchers argued that the chemistry of the accretion ice showed patterns consistent with a stable, long-lived aquatic environment. The balance of salts, the presence of certain gases, and the structure of the ice itself suggested slow movement and gentle circulation within the lake. These conditions, they said, could support microbial ecosystems adapted to cold and pressure. Others were not convinced. They argued that until uncontaminated samples were obtained, no biological conclusions should be drawn. From their perspective, the data was interesting but unreliable. This disagreement did not come from denial, but from discipline. In environments this extreme, false positives are a serious risk. As this debate unfolded, attention turned to how scientists might eventually reach the lake safely. Lake Vostok sits under strict environmental protection. The Antarctic Treaty System requires that research causes minimal impact. Unlike underwater archaeology projects that explore sunken structures or lost underwater cities, drilling into a sealed subglacial lake carries permanent consequences. Once contaminated, it cannot be undone. These concerns caused major delays. Drilling plans were halted, redesigned, and reviewed repeatedly. International teams debated new techniques, including sterile hot water drilling that would melt through ice without chemical fluids. But developing and deploying such technology in one of the coldest places on Earth takes time and funding. This is why Lake Vostok is sometimes described as forbidden, though not in a dramatic sense. It is not hidden by secrecy, but by responsibility. Scientists are not blocked by fear or lack of interest. They are restrained by the understanding that this lake is a rare natural archive. It may preserve conditions unlike anywhere else on Earth. Today, what science knows about Lake Vostok comes almost entirely from indirect evidence. Ice cores, radar scans, chemical traces, models built from physics and geology. It is similar in some ways to studying submerged civilizations before divers ever reach the site. The outlines are there. The hints are strong, but the details remain just out of reach. And that is the heart of this chapter's mystery. Lake Vostok is not unknown. It is partially known, carefully studied, and deliberately left untouched. The challenge now is not discovering it exists, but deciding how to learn more without destroying the very thing that makes it worth studying. By 2012, the long wait reached a turning point. After decades of planning, delay, and redesign, a Russian research team working at Vostok Station finally reached the surface of the lake itself. The moment was careful, controlled, and quiet. Nothing like a dramatic breakthrough. Instead of breaking the lake open, engineers used a method designed to respect the isolation scientists had worked so hard to protect. When the drill stopped just above the lake, the pressure difference allowed lake water to rise naturally into the borehole. That water then froze as it climbed, sealing itself off again. It was a historic first contact, but it was also deliberately limited. No open hole, no direct sampling of liquid water, only frozen material that had once been part of the lake. For many researchers, this was the only acceptable compromise between curiosity and responsibility. In the years that followed, samples from this refrozen lake water were analyzed by different teams. Some results hinted at biological markers, including complex organic molecules that could be associated with microbial life. These findings were careful and restrained, never framed as proof. Other scientists, reviewing the same data, reached different conclusions. They argued that contamination remained a serious concern and that the samples were not clean enough to support firm claims. This disagreement remains unresolved. No scientific body has declared that life has been confirmed in Lake Vostok. At the same time, no one has ruled it out. The evidence sits in a narrow space between possibility and uncertainty. That space is uncomfortable, but it is also honest. What makes Lake Vostok different from many deep-sea mystery stories or ancient ocean discoveries is not what has been found, but how cautiously the search continues. There are no ruins, no sunken structures, no lost underwater cities waiting to be photographed. Instead, there is a real physical place that exists beyond direct human reach, studied through layers of ice, data, and debate. Scientists today view Lake Vostok as a natural laboratory. It offers a rare chance to understand how environments function when sealed off for immense periods of time. How does water circulate without wind? How do chemical systems balance themselves without surface input? If life exists there, how does it survive with no sunlight and limited energy sources? These questions are not about spectacle. They are about limits. Lake Vostok helps researchers test where life can exist and how fragile, isolated ecosystems may be. That knowledge matters here on Earth, especially as climate patterns change and polar regions respond in unpredictable ways. Yet the path forward is not clear. New drilling technologies are being tested elsewhere in Antarctica, including sterile hot water drilling systems that reduce the risk of contamination. These methods have been used to access smaller subglacial lakes with promising results. Even so, Lake Vostok remains a special case. Its size, age, and symbolic importance place it under heavier scrutiny than any other site. Some scientists argue that continued delay carries its own risks. Ice sheets move slowly, but they do move. Over long periods, pressure changes and melting patterns could alter the lake naturally. Human activity on the continent, even far away, could also have indirect effects. From this view, carefully planned exploration may be better than waiting too long. Others strongly disagree. They believe Lake Vostok should remain untouched until technology improves further. Once contamination happens, even accidentally, The original conditions are lost forever. There is no second chance with a place like this. Their position is not driven by fear, but by patience. This ongoing debate is not about secrecy or control. It is about choosing the right moment, if that moment ever comes. Unlike underwater archaeology projects that return to submerged civilizations again and again, Lake Vostok offers no easy return. Every action carries weight, and that is why the mystery still matters. Lake Vostok is not mysterious because it hides monsters or ancient machines. It is mysterious because it represents a boundary. Humans know it exists. They know its size. They know its age. They know it could change scientific understanding of isolated environments. And yet, they have chosen restraint. Beneath Antarctica's ice lies a place that challenges how discovery works in the modern world. Not everything unknown is meant to be rushed. Sometimes the most responsible choice is to wait, observe, and accept uncertainty. For now, Lake Vostok remains mostly untouched, quietly holding its secrets beneath 4 kilometers of ice. And that balance between knowledge and restraint is what keeps this story alive.